So let's look at the dreaded friction problems, right? And these really aren't all that hard. They're all about the same. So let me just walk you through these things, okay? The notion, the overriding principle here is that as this car goes around the corner, the force of friction is equal to the centripetal force. Does that make sense? Okay, so that when it's just barely making it around the corner, um, then the force of friction is going to just equal the centripetal force. And this is just generally true for if it's a level surface. Now, if it's tilted or banked or something like that, it gets a bit more complicated, but we're not going to go into that. Okay. Now, remember, the force of friction is mu times m times g when the surface is level. And the centripetal force is either mv squared over r or m 4 pi squared r over t squared. Okay, so either one. Now in this case, I'm giving you a velocity, so it's this one, and it's not that one. Okay, but if you the ones where you have a period, then you're gonna have to use this one when it tells you how long it takes to go around. So anyway, let's just work through this, right? So what is a centripetal acceleration? We can do this in steps, right? And then I'll just show you how I do it, right? So our centripetal acceleration is v squared over r, so it's 24 squared divided by 80. This is our corner, right? Okay, and 24 squared over 80 divided by 80. That's actually 7.2 meters per second squared, right? So then it says what centripetal force is needed. Well, F still equals ma, right? So I don't have to say mv squared over r. I could just go m times this number, right? So that's 1200 times 7.2, which is mathematically the same as mv squared over r because 7.2 is v squared over r, but we're doing it in pieces here, right? So 1200 times 7.2, and that's 8640, right? All right. So then the final question is, what's the coefficient of friction you need? Well, we know this is the centripetal force. We also know that that's going to equal the friction force, right? So friction force is mu times m times g, right? And so 8640, which is our centripetal force, that has to be our friction force. And that's going to be mu, which we don't know. But we do know m and g, right? So we know this is 1200, and that's 9.8. Okay, so now if you watch, right, I'm going to take this 8640, I'm going to divide by 1200, I'm going to divide by 9.8, and I get that mu is, the coefficient of friction is 0.73469 or something like that, right? Roughly about 0.73. Okay, so this is doing it in pieces. I tend not to do it that way because there's advantages to just sort of looking at it this way, right? If you set the formula equal to the formula, right? So formula for friction equal to the formula for this. Notice that the mass cancels, and this is interesting, right? We don't even need to put the mass in there. And this is because although a more massive car takes more force to go around a corner, it also generates more friction force, and it does so in the same exact proportion. So it doesn't really matter. Okay, I think that's kind of cool, right? But anyway, I'll do it with or without, putting the numbers in or something like that, right? So our coefficient times 1200 times 9.8, I'm not canceling out the mass, right? But I will here in a second, equals 1200 times 24 squared divided by 80, right? Now, watch what happens. If I just cross these out, now I can do some maths. I can do this and divide it by that, and then ultimately divide that by 9.8. And we'll come to this great physics truth. So 24 squared divided by 80 is 7.2 divided by 9.8 is exactly what we got before. Mu is 0.73469, etc., or about 0.73. And remember, the coefficients of friction don't have any units. Okay, so if we want to just arrive at the coefficient of friction, there it is, right? Now go ahead and leave the 1200 in there. Notice that you're going to multiply on this side by it, right? And then on this side, you'll divide when you try to get the answer. So it really doesn't matter, which is kind of cool. I always give you masses just because some kids are like, well, I must calculate this number first and then do this, right? It doesn't matter how you do that. Okay. What else was I going to say? And 0.73, by the way, that's counting on a lot of friction. You know, tires on a road reliably are 0.8, right? But do you really want to rely on that? This person's really kind of pushing it. Your parents would tell you to slow down if you were driving this fast.